My name's David Barkaway. I work for Trifacta on the technical side, and what I was hoping to cover in the next 30 minutes is spend 10 minutes looking at DataOps, how wrangling fits into DataOps, then spend 10 minutes looking at what wrangling actually is, data wrangling, how Trifacta assists in the DataOps process, and then assuming the Wi-Fi is fast enough, we'll go into product. We can have a look at the actual product itself. We can look at the interface, how it works, how it's really good for the business user. And then if you have any further questions or want to delve into anything in more depth, as stands 426, and happy to answer questions there afterwards. So, if we look at DataOps itself, I mean, this is a very succinct perspective. Basically, it's all about the data journey from the source system to how you get value. It's basically evolved out of development operations. There were obviously inefficiencies that were there, very long cycle times, people weren't delivering around analytics. And what we've seen a process and methodology built, a very automated process that uses both business and IT to deliver a solution to improve the quality of data from source to target, and to automate and make that as efficient and reduce the cycle time as much as possible. Okay, so before we delve into a really good DataOps solution, let's look at some of the things that I've generally seen in organizations, really inefficient processes that exist out in the business. So what we've generally seen is we've seen three sort of loops of analytics that are really inefficient. We've seen what we call dependency loops, batch loops, and what I would call disconnected loops. So going into these types of things, the first one is the dependency loop. We generally see these in large organizations, okay, that can spend a lot of money around IT. And what you have is you have the business separated from IT. They have their databases, the spreadsheets, the IoT sensors, all of their sources out here, and IT own this, and they're generally separated. Line of business goes out, they said that we'd like to do some analytics, and they have to communicate with IT to get their data. And what actually happens is they ask for the data over a period of time, and this can be very dependent on your job title. So someone like chief in their job title, it may be hours. An intern that may be doing some analytics, maybe months before they see their data actually arrive. But basically, you've got your business there, they're asking for the data, it's extracted, it's put together, it's prepared, and then delivered to the line of business. But it takes a long time, the cycle time takes ages. They ask for help, they wait for it, there's a lack of communication, there's no collaboration between the business and IT. And as I say, this could be, it's large organizations. I was working with a large bank. They have 1,200 people offshore just preparing data and providing it to the business. So very inefficient, very long cycle times. There's no agility there. The other type we see is the sort of the batch, what we call a batch loop. Another inefficient process. What actually happens is someone's using, and you see a lot of this with the traditional ETL types of tool. Very IT oriented. You define your process. You may have multiple steps to transform your data. You could actually be hand coding it. You execute that on a large amount of data. It may take hours to run. You get your results. You see an inconsistency in the data. You then fix it. You make your edits, and it just takes a long time to deliver the actual data in the right form to the business so you can do your analytics. The last one is what we've seen more recently with the sort of the advent of self-service business intelligence. Here you've got the business going out, either using Excel, using a self-service BI tool. They've given up with IT because IT is not delivering the data. So they get a friend or someone in IT maybe to provide a raw extract of data, and then they work themselves, maybe in Excel, cutting and pasting, pivoting the data, and then doing their analytics. And the problem with this is you end up with lots of little silos, everybody duplicating the data, making their own cut of data, building their own solution. You end up with semantic inconsistencies, people with different values because they've implemented it in different ways. So here, you've got a major problem, you've got repeated work, there's no reuse, you've got duplicate data, inconsistent definitions of net profit and the metrics and KPIs the organization is using. So how does Gartner see the data operations platform? So this is what they see is happening in the market now. You've got your raw data on the left-hand side. You've got your existing, what we call EIM solutions, your ETL technologies, your Talons, your Informaticas. You've probably already invested in these types of solutions to extract the data. So what we're seeing now is these environments are potentially populating your data lake. It could be a Hortonworks, it could be a Cloudera, an on-premise solution. It could be an S3 environment on AWS, blob storage or something like that on Azure. It could be BigQuery on Google. But they're landing the raw data in the data lake. You may have your enterprise metadata management environment, which is cataloging this information. But once the raw data arrives in your data lake, what you're doing is basically cataloging it so you can access it. You know what raw data is there. And then you have this process of taking the raw data, refining that data, and putting it in an environment to then use your analytics, your machine learning, etc. And you may be plugging into your enterprise data management platform, your DQ environment, your data quality, to ensure that this is clean data that's being delivered. This is where we see the wrangling, okay? And when you're looking at a DataOps process, there's collaboration between IT that may be doing this part. This is where we expect the business, they understand the data, they understand how that data is being used, so they're defining this process here, the wrangling process of taking that raw data, refining that data, and then consuming it in the machine learning or your BI analytics platform at this end to get value. The other aspect of the DataOps process is you're obviously optimizing, you're automating this process. So this flow that's been defined by the business user needs to be able to be scaled and take advantage of the native environment in the cloud platform or potentially on-premise. So you should, for example, be generating maybe Spark code that runs on EMR or on Databricks, or it may be using the native services of Google where you're using Dataflow, or if you're on-premise and you're using a Hadoop cluster, generating Spark to go on Cloudera or Hortonworks and using all of the nodes and the capabilities that are already there. The other thing that we've seen with DataOps is the shift over the last few years. Who owns the actual process? It's gone from IT mainly across to the business part of the organization. They're leading it, they're driving, they have the budget, and they control the actual process. And we're seeing that much more with the collaboration, who's defining these processes as well. Historically, we've been taking the data out of transactional systems, your SAPs, and things like that. Now it's the actual data is not only the transactional data, what's been sold, when it was sold, but why was it sold? It's actually the interactions. It's your Google Analytics, it's your Twitter feeds, it's your sentiment. People want to understand the behavior, how customers are actually interacting with the actual environment. We've seen a massive shift from on-prem. So usually you had your Hadoop clusters as your data lake. Now we're seeing very much a hybrid. People are on-prem and in the cloud. And if they're developing data flows, you need to be able to, you're migrating from on-prem into the cloud, you need a simple solution that enables you to define it once and deploy on-prem and in cloud, or maybe across multiple clouds, taking advantage of those environments. And from an organizational shift, less of the waterfall approach and the top-down, it's much more of an iterative, constant evolution of these data flows and a collaborative process. So looking at your source to your target, what we generally see is about 80% of the time is actually sorting out the data, cleansing the data. I mean, this is from a quote from your chief data scientist that supported Obama. 80% of the time is basically sorting out, cleansing, formatting, ensuring that the data is in the correct format, it's clean before you do your analytics. And this is, this has been said, this is basically Harvard Business Review. There's a lot of money being spent on AI and machine learning, and there's a sort of a war going on trying to find the best models and the best algorithms to use on your data. But if the data's not of good quality, it's not timely, it doesn't matter how fantastic the algorithms are. If the data's poor, you're going to get poor results. And it impacts the entire team. If you look at the data operational team, you've got your data analyst coming from the business, you've got your engineer who knows how to get the best performance from source to target, you've got your scientists that are working with the actual data. All of them obviously rely and need to know about the quality of the data and need to know that it's of good quality when it arrives here so they can use it and get the best value from it. And this is recognized by the actual, the major players in cloud, okay? You've got your on-premise, your Clouderas, they work with us around with our technology, Trifacta Wrangler. We support the Hortonworks, we support Cloudera native technology. Google Cloud actually use our technology and provide a service. So if you're using GCP and you're using data prep, that's actually our product. So we're actually on this platform as a service. With respect to Azure, we totally support, and we integrate with all of the security on these platforms, and the same with AWS. We'll push down to EMR, we'll push down to Databricks and HD Insights. Here we'll push down processes and use Dataflow. And here we're generating Spark and pushing down the processes to the Hadoop cluster. So from our perspective, we obviously fit in to this process from source to target. We're complementary to the EIM technologies, but we're designed for the business user. When we actually access the data, we automatically assess the data, we profile it. If we're connected to terabytes of data, we'll automatically sample that data. Immediately, we present the data to the end user and we assess it, and we provide you a data quality view of that data. When the user starts interacting, we're using machine learning algorithms to actually push and suggest the transformations. If you're looking at a date, do you want to change the pattern? If you're looking at a URL, do you want to extract the domain? Okay? So we'll automatically suggest transformations that the business user may want to use. It's a collaborative environment, okay? So multiple users in a Google Docs fashion can work together on the actual process, And it's an enterprise-wide platform, multiple connectors. We can bring in JSON data, we can connect to Snowflake, all the different sort of environments, be they relational, structured, unstructured data, and we can be deployed on all of the actual major platforms out there. So if we're looking at the process, you're discovering what's out there, you're structuring, you're cleaning, you may be enriching this data, validating, and then deploying at scale across the organization. Whether you're doing predictive modeling, you may be doing BI, bringing data and onboarding that data into a new application. You might be migrating the data from on-prem into the cloud, or if you're in a finance, you could be doing risk and compliance and specific reporting requirements or audit processes. From a customer's perspective, our technology is used across all sort of verticals, be it governments, financial services, insurance, telcos, people like NASA. A wide variety of different organizations are using the technology for multiple use cases. So why are they actually using our technology? The main thing is it's self-service, it's speed, not only in the development, but also in the when it's deployed, and the fact that it's not something that's been developed on premise, but it's been developed as a cloud native capability when you're deploying it in the cloud. So from a self-service perspective, we've made the actual interface very business oriented. You'll see that it looks very much like Excel. An Excel user could come in here and be very productive extremely quickly. It's an intuitive interface. We profile the data as it comes in, so that's incorporated, so you get your data quality view at the top, all your functions are there, and as the user interacts and starts creating the actual steps to prepare and clean the data, it's very readable, so anybody else that's coming in and collaborating in this environment, they're not looking at some complex code, it's English-like steps that they're actually working with. And you can move backwards and forwards and see the transformation to the data as you sort of click between here. So you can see the actual steps and the impact of those steps on the actual data. So it's self-documenting, it's auditable as well as part of the actual process. The other aspect is if you're using a traditional ETL tool, your Talons, your Informaticas, you have to define the process, execute on the actual data, then you see the result. Here, what's actually happening is the user clicks on a column, they start manipulating the data. We prompt them with the machine learning to say, well, okay, you want to convert, you want to extract this value, you want to concatenate this data, you want to standardize this data. You see the before and after step. So you can see the impact of every single transform immediately. So you're not having to wait to execute the actual process to see the actual results of the transformations. So you can pick and choose and say, yep, that's what I was expecting. I'll add that to my recipe. And once you're finished, you end up with a pipeline. Here's your source systems. You've got your target data. It's your refined data that's going into, maybe a machine learning model. You can share the actual flow. And also, the DataOps team will be picking up this and deploying it at scale. We'll be generating that Spark process that can be pushed down to the Hadoop cluster, or you're pushing down to EMR on AWS or to a Databricks cluster. We'll automatically spin it up. We'll execute the actual flow, maybe across terabytes of data, and then bring it down in an elastic fashion. And the other aspect is when you're deploying, we have full version control management across the different environments. So, whether you're deploying in AWS, we'll be picking up the data maybe from S3, populating a Redshift or a Snowflake environment, pushing down to EMR. On Azure, you may have ADLS, loading into SQL, let's say. We'll be pushing down to Databricks, and within the Google environment, you're using Google Data Prep, and we'll be generating data flow processes automatically, taking advantage of the infrastructure that's there, and tying also into the governance and security framework of these environments. If you look at things like the analyst reports around data wrangling as an area, we come out top, okay? So if you're looking at things like the Gartner Peer Insights, Ovum, Bloor, etc., or Forrester, I think they do their report every other year. So this was 2018. There'll be one again next year probably. We come out top as a technology in this area. So what I'll do is I'll switch. I've got 10 minutes. So what I'll do is I'll give you a brief overview of the product. So let me switch out of here. So hopefully the network and the Wi-Fi is up to speed. I apologise about size of screen. I'd have no. So what we've got here is we're using a browser. Everything's browser based. Okay. There's no client install. I've connected to some data. I've got some advertising clickstream data. I've got some sales data, and they've been dropped into my flow. I want to now cleanse the data here, get an idea of the quality, link the data, and then execute it and deploy it. So from a connection perspective, if I want to bring in other data, what I can do is I can connect to the data lake. We can see all the sources, all of the different data I've got, the actual HDFS in this case, Hive, when it was last updated. If I want to go externally, we've got multiple connectors. Okay, so here we've got on the left-hand side, I could be bringing in some JSON data, Parquet, connect to HDFS. We also support the catalogs, likes of Waterline, Elation, Calibra, IBM's Watson catalog. We got Hive, we got relational sources out here, so I can just connect to them natively and basically import that data, or I may have a spreadsheet or something on my desktop that I can just want to drag and drop. So we'll connect to those, and we could go outside. I could make another connection, go out to Salesforce, all these different sources, and then bring that data in. Once we've got the data, I want to start wrangling. So what we've got, I can just edit the recipe, and what it does now is it actually samples. If this is a terabyte of data, it will sample the actual system. I can define the actual sample. I can define the sample. So do I want a random, first rows, filter-based, anomaly-based sampling? And we assess the quality of the data. So up the top here, what you can see is the bar. Green's good, black means I've got nulls, and red I've got a problem. We've also got a very Excel-like interface. Okay, so all of my transformations are here. All right. If I want to look at the specific functions, maths functions, aggregation functions, I can see them. And I can see quite quickly I've got a problem here with the event time. Clicking on it gives me a bit more detail. So we've assessed the data. We can see we've got some timed out, some values that are timed out. So what I can do is I can actually just interact with this, click on it, and then the machine learning algorithm says, well, what do you want to do with this? Do you want to keep the rows? Do you want to delete them? Do you want to set a specific value? So in this case, I'm just going to remove those ones, and I'll just add that to my recipe, and we immediately update the actual profile. And I've now got a new step in my recipe. So go in here, I can still see I've got a problem. Maybe I want to go into more detail with this. So now we get much more detail. It's a date time, so we got breakdown by month, weekday, day of week, etc. And it's telling me you've got some mismatched values. So what I may want to do is I may want to look at the patterns for these, because I can see that I've got different types of pattern for this. So let's switch across to the patterns. 3 types of pattern. If I click on the top one, it'll say, well, actually, what do you want to do? Do you want to convert all of the other ones to this? So this is what it looks like before. this is what it looks like after. I don't have to execute to see the results. It's telling me immediately. So yep, that's useful. Let me just add that to my recipe. And now everything's green, so we've sorted out the date. Okay, so going back to the data, it's set up my steps. I've got a step here. Let's go across, let's look at this. So let's click on the URL. And it's saying, okay, you're looking at a URL here. Slightly different thing. We've got a domain. Do you want to actually pick up the domain? Yes, I do. I'll add that to my recipe. So now I've got a new column. It's extracted the domain from the URL automatically. I can also see I've got a product code on the end here. So on the end of the URL, I've got the product code. So what I may want to do is I may want to brush this. And what it said is I'm seeing a product code on all of these. There's some with different, numeric with 3 at the end, 2 at the end, but you probably want these. And then it's suggesting and saying, well, what do you want to do? Do you want to bring these out and use these? So basically, I'm going to extract and say, yep, I want this in a new field. I'm going to call this product code. Okay, so I'm going to rename that and call it product code. But if you've got an unstructured thing, I mean, I was working with a bank. They wanted to look at the influence of news bulletins where on the actual stock price. So we were picking up an unstructured data set here. It had ticker codes in there, and we were just brushing and bringing those out and incorporating them and linking them back into the actual prices of funds. So as news was released, how that was actually influencing the prices. So we've got this, and we'll add that there. Now I've also got another data set here. I've got the actual more complex structure. Off to the right here, I've got a very complex JSON nested structure. This is what the actual values look like. So every line for a person has multiple sales lines, and this is all nested in this column here. So if I just click on this, what it will do is it'll actually recognize this, and it says, okay, do you want to flatten this array? So do you want to bring out every sales line item and flatten these? Yes, I do. So we'll just add that to the recipe. So we've suddenly gone from 3,000 to 12,000 records now. And then I want to actually bring the columns out. So of this item, what I want to do is actually unnest and bring all of these items that are nested in this structure out of columns. So let's do that, bring it out, and now we've got a very flat structure that I can use for analysis. Okay, so last thing I'll do is let me just join this back in. So I want to join this across to the other data set. So what it's doing is it's analyzing the two data sets now. It's prompted me and says, well, actually, I can see product key over here and product code. It looks very similar. But if I look over here, it's saying there's only a 2% match. So maybe I want to change this. We support things like fuzzy matching. If you haven't got a standard key, we can use metaphone, double metaphone functions and things like that. It's actually saying there's another key you could use here. You could use customer key and user ID. Well, that's probably something I want to do. That's much better. I'm getting an 82% match. Gives me a breakdown before I even start doing this. Let's press next. I can select the columns. So here I can see it's all color-coded left and right. Okay, and now we've got this. If I scroll down a bit more, I should be able to, I'm running out of screen size here. Let's review, add it to my recipe. So it's now joining the data. Now I haven't actually touched the source system at all. This is all metadata driven. I haven't actually executed this yet. But now we've got the actual consolidated data. If I go back to the flow at the beginning, it's built the flow. We pre-processed the actual advertising data. We've joined it up. I can now run this at scale. So clicking on here, we can run the job and execute it. I can share the actual process, we can schedule it, we've got an inbuilt scheduler, and we can collaborate on this. I can share this with multiple people. And that's basically it on the time. So going back into here, I just wanted to show you one last thing. Going back, if I go to here, because we're right out of coming to the last minute. Well, if you want to actually look at the technology yourselves, we actually have a free trial. So if you go to the stand on stand 426, you can pick up an actual free trial information. You can also start wrangling on a small set of data. We have a free environment that you can actually use. But if you have any further questions, please come up to stand 426 and happy to go into in more detail about the actual product and answer any questions you may have. Thank you very much.